Hello, everyone. Thanks so much for being here today. This is one of the BECP webinars as part of our webinar series. And today's webinar, we will be talking about the new ASHRAE standard 90.1-2022. So everything you need to know about the new energy standard for commercial buildings. And this is part of a series, as I said. We are here the third Thursday of each month. We are taking next month off, December, but we'll be back starting in January. So we'll be covering some topics such as, understanding and improving code compliance, existing buildings, and energy code enforcement challenges and opportunities in rural communities. So feel free to go to that website and register for some of our upcoming webinars. Before we get to the presentation, I'm just going to do a couple of quick logistics. So this webinar is being recorded and we will post a video of the webinar online in about a week. That'll be at the same webpage that you'll find a PDF of the presentation that is available now. So if you'd like to follow along in the presentation, open that, download it. You should be able to access that on the webinar series webpage as well. We encourage you all to ask questions anytime, but please use the Q&A function on Zoom. So we are going to be monitoring Q&A and we'll make sure to relay all those questions during the Q&A with all of our speakers at the end of the presentations today. And finally, CEUs are available from AIA and ICC. So if you're here, if you're watching the live webinar, you're going to have the ability to request those CEUs through a link that we will provide at the end as well. So keep your eye out for that. You just click into that link, put your name and information there, and you'll be given a certificate and CEUs for AIA and or ICC for attending today's webinar. So here are a few learning objectives that we will be covering today. And more importantly and excitingly, we will have 6 great speakers, members of the SSPC 90.1 committee, and we have Don Brundage, Len Sciarra, Michael Meyer, Richard Lord, Michael Toulouse, and Michael Rosenberg, who are all going to be presenting on ASHRAE 90.1-2022. I think that's it, unless there are any other questions before we get started. So I believe we will start sharing the ASHRAE presentation, and Don will kick us off.
Okay. Hello, I'm Don Brundage, formerly with Southern Company. I'm currently retired. And we're going to be talking about what's new in 90.1-2022. Next slide. Next slide. Okay, we seem to have technical difficulty here.
Yeah, Don, give me just a minute. I want to make sure that I'm sharing the right screen.
Okay.
So if you want to go ahead and just start with, continue with what you were talking about, I'll get the slides up here going for us.
Okay. Well, 90.1 is a standard used to define minimum building efficiency requirements for commercial buildings. And in typical ASHRAE fashion, we tell you what it's not rather than what it is. It's applicable to all buildings and sites except for residential buildings less than or equal to 3 floors. Standard covers minimum efficiency requirements for building and construction plans for operation and maintenance of new buildings and their systems, new portions of buildings and their systems, new systems and equipment in existing buildings, and new equipment or building systems specifically identified in the standard that are part of industrial or manufacturing processes. That has caused a lot of concern for people at times. We're not going to tell you how to make plastics or melt steel or something like that. But if there's processes that are really related to expertise of ASHRAE, then we might set standards to try to save some energy on them. Some examples of that are HVAC needs in a laboratory, which is not for human comfort and wouldn't normally be within the standard. Can we go back to page 3? Okay. Okay. Anyway, there's things like laboratories or indoor agriculture that would be applicable within our expertise. So we'll set some standards for that. It's continuous maintenance standards that's updated and published every 3 years, 2016, 2019, 2022, 2025. And I was the chair of the committee during the 2022 cycle. The learning objectives for the day is provide an overview of the changes that are included in the 2022 published edition. There have been a lot of changes along the way for this cycle, but there's also several new approaches for compliance requirements. One thing to watch out for is there have been some renumberings of sections that have been the same for many years. So be careful. Don't refer to section 11 for ECB anymore. In the 2022 edition, it's section 12. And we will provide details at the end. We'll have time at the end for questions. Okay, can we go to slide 4? Four, not 14.
So the numbering might be a little bit different on here. I'm not sure which slide you want to go to.
Okay, the agenda slide.
Okay. There we go.
Okay, I'm going to do the initial introduction, and then we'll get into the different sections here, and we'll have time for questions at the end. One minor correction: I am retired for the last few months. I'm no longer associated with Southern Company, which is a major electric and gas utility, mostly in the Southeast, but also with gas in the Chicago area. Okay. Scrolling forward to page numbers, go to the overview of changes. Okay. We only went up about 30 pages this time, which is the standard is getting very long. These number of addenda can be misleading because some addenda are like 2 or 3 lines and others run 12 pages. We've added some new sections, additional energy efficiency requirements, which is also called credits, where there's a certain number of required credits in order to pass the standard, which gives you some optionality on choosing what to do rather than simply meet a very strong prescriptive standard. There's a new Appendix I, using other metrics with Appendix G. This is usually used for carbon emissions, but I believe also has source energy. There's a new Appendix J, performance curves for chillers. This is used for baseline models for ECB and Appendix G, and a new normative Appendix L, which is a performance based system for the mechanical section. The next slide. Okay, here's the renumbering, because for many years, energy cost budget method was section 11 and references were 12. So now the energy credits called additional efficiency requirements are section 11. ECB goes to 12 and references goes to page 13, section 13, excuse me. Next slide. Okay, and here are the new ones. As I said before, I is the carbon or source energy metric that can be used with Appendix G. We have performance curves for use with Appendix G and for ECB to provide some standardization of that. There's some figures for the envelope section to help better understand how thermal bridging works. And then, as mentioned before, the mechanical system performance rating method. Next slide. This is energy standard for sites and buildings. There's several reasons that we did this. One of them is we had, particularly for lighting, we realized there was a loophole. You could, we had requirements on exterior lighting, and then found people were going off-site off the building and illuminating a building like it was daytime, and we couldn't control it because it was off-site. And also parking lots were kind of murky. There's also the whole issue of renewables. If it's not actually on the building, it could be hard to define whether you could get credit for it. So that solves all that and provides the capability that we might be able to better incorporate campuses within the standard where some energy systems are not necessarily located on the side of the building. So this is an improvement and really needed to be done to because of some of those murky situations about whether something was or wasn't part of the building's energy systems. Next slide. And that's it for the introduction. And now I'll pass it on to Lynn Sciarra, who will tell you about the envelope.
Hi, next slide, Rosemary. So my name is Len Sciarra. I'm an architect. I work primarily in Chicago, but I've been working on 90.1 for a couple of years, so pretty familiar with all the climate zones. So Section 5 deals with the building envelope, and in the base criteria we have insulation requirements for walls and windows, but there's a lot of other little pieces in there to the building envelope that are in there. And when we made the changes for this go around, I sort of broke them into two sections. One is there was an existing requirement that we made more stringent or we changed. And then there were some new concepts that were never in the standard that are sort of, we realize are cost effective and are really, really potential energy savings. So we're gonna go into the kind of updated requirements and then the new concepts. Next slide. All right, so one updated requirement, there's actually it maybe straddles between new, is we updated the air leakage requirements. I'm sorry, I'm in Chicago and I'm in a really old building that has just single pane glass, so you can hear all the sirens. We always had air leakage requirements, but they were sort of install a continuous air barrier and do some inspections. There was no requirement to do testing. You can do testing if you want, and if you do testing, you take credit for that in the trade-off method, but it was not required. We've now made it mandatory for small buildings. So this is important, right? All small buildings need to do a blower door test. And the target we chose, 0.35, is not sort of like super stringent, right? It's not Department of Defense, 0.15, 0.25. And then, but it's reasonable. And then there are some exceptions, right? Not every building has to do it, but basically we're trying to encourage small buildings would need to do it. Next slide. The other thing we updated the roof replacement section. And what we found was that when people re-roof, that is a great opportunity to increase building efficiency. Roofing happens all the time. It happens on a much shorter time cycle than, say, replacing windows. And it's a great opportunity to reduce the energy use of buildings. And so what we did is we had more clarity in the existing building section on what you need to do to re-roof and when you need to upgrade the requirements and when you don't need to upgrade them. Because there was a lot of people would just throw their hands up and say, oh, I can't do anything. It's too difficult. we're basically made it a little bit more difficult for people to throw their hands up and say, I can't do anything. But realizing there are significant, as you can see in this photo, there are significant issues with existing roofs and curbs and stuff. And so we're trying to mediate between sort of what you can do and what, in an ideal world you could do. So the next update was envelope commissioning, and this was covering all the sections. We sort of looked at all the sections over the years, and there was like different testing requirements and commissioning requirements all sort of filtered in. So what we did is we now have if you look at all the sections, there's a 9.1 section. So like 5.9.1, 6.9.1. This all has the testing requirements. So sort of functional testing, something that a manufacturer would do or a subcontractor. And then the next level for larger buildings, larger systems is like systems commissioning. And so that is all under the 9.2 section. So 5.92, 6.92, 7.92, those are all in the 0.2 section. So when you look in the standard, all of the what we're calling functional testing, and Michael will talk about sort of lighting functional testing, that all happens in the 9.1 section. And then the more robust commissioning is all 9.2. So it's super organized for when you're doing project specifications or policy. Next slide. The other update we did, two other updates. One was insulated metal panels were starting to be sort of a big thing, and they weren't like a thing. So we specified like where an insulated metal panel needs to fall into the standard. They're mostly used on sort of warehouses, big box, not too many big box, mostly warehouses and some data centers. And then there's a new standard coming out for metal studs. Lots and lots of buildings are built with metal studs. Like they're used all over the place. And we have basically two tables, one for 16 inches on center, one for 24 with one gauge of stud. So there's a new standard out. It's called S250 from ANSI, and it allows a designer to essentially build a custom wall and come up with a U factor. You can do it by hand. It's kind of a pain. There's a lot of weird stuff that happens with the metal and the flange and the size of the flange. So basically you can put in the calculator, the type of stud, the gauge, the spacing, and come up with a U factor that you can then use to show compliance. So that's like super helpful. And now that's allowable. Next slide. Okay, so these are the new concepts. I probably should have put a break. So new concepts is we added a requirement for wall reflectance. So kind of like we know that light colored roofs, high albedo roofs in warm climates are energy savers. The same holds true for walls, right? I mean, if you were to think about a building in Florida, right, you'd like, a white building is going to be a little bit use less energy than a black one. So we've added a requirement for wall reflectance. It's a little, it's not, again, super stringent, right? We sort of, have these broken the world of color into sort of the darks, the kind of grays, and then the white colors. But it's, and we sort of set a requirement at the mid range, and we could go more aggressive. This is only for climate zone 0. So the thing is, the climate zone 0 doesn't exist in the US, but the plan is to introduce this to the market, introduce the requirement, allow teams to trade off. So if you are working in my climate zone 1 or climate zone 2 and you do a cool wall, there's a method now to capture that energy savings in chapter 12 or appendix G. As well as the Cool Roof Rating Council has now taken on this mantle, and they're coming up with if you'll Google them, and we can put that in the chat. There is a cool wall directory. There's a cool wall standard, and then manufacturers are certifying their products. And kind of, I don't know if you guys know, but metal roofs, you can get a cool metal roof in all different colors. So there's things you can do with pigments and infrared reflectance to make a dark color appear cool, other than just painting it like like a light color. Next slide. Okay, this is like the big one. Like, I don't know if you've heard anything, but thermal bridging was like sort of a big loophole. We didn't really have a lot of the technology, the math to make it all work. But ASHRAE and all their their copious spare time has been working really hard on developing a methodology to calculate thermal bridges in building envelopes. And so we've introduced a requirement, and it's in the tradable section. So you can trade it off, which means, you know, in 90.1, there's mandatory requirements, you have to do them. And then there's tradable requirements. Air leakage is mandatory, you have to do it. Thermal bridging is optional. You cannot do it, but you have to make up for it some other way. So next slide, I think I have my categories. Like anything in ASHRAE, there's exceptions. So we start light, and we're not making every building everywhere calculate this. Next slide. And then these are like the big categories, and we could spend hours just talking about thermal bridging, but we've really broken the thermal bridging on the envelope into these 5 sections: roofs to walls, floor balconies, intermediate floors, cladding support, window frames, and then basically everything else, big canopies, signage, big things. And so we have requirements for all these. We have suggested constructions, as well as what we call a default psi factor. So psi being a linear thermal bridge, chi being a point thermal bridge. We have default factors that can be used in a trade-off. And the concept is really, if you're doing it, you just check, you basically says, yes, I'm complying with the prescriptive requirement. If you're not doing it, you would move into the envelope trade-off option in Appendix C, and all this math is built into there, and say, I'm not doing my thermal bridge. And then it would say, okay, well, you need to do a little bit better window, or you need to do a little bit better wall, or something of that nature. And then of course, if you do whole building modeling, that's like, you can trade it off with lighting systems and mechanical. So that's all in there. And that's one of those big appendixes that that Don was talking about, where we added a bunch of pictures, because this thermal bridging, you can only use words so much, and we really need to sort of have some visuals on that. Next slide. And then here's just a picture of some thermal bridging. This is sort of what is going to be happening in the future. There's steel to steel connections, there's concrete connections, there's framed wall connections. So, we're moving into sort of these high performance plastics on some of these. So, all right. I think that's the last slide for me, and it's on to lighting. Thank you.
Thanks, Len. I think the pictures were helpful understanding thermal bridging. Next slide, please. So I'm Michael Meyer, and this is the first section, is section 8. It's power. That's what we use in the building to operate the building, loads and different things like that. There were 3 kind of major changes. One is we already required energy monitoring. So the idea here is it's helpful to know what loads you have in the building and what they're using to get a sense of how to make improvements. There was already a certain set of monitoring requirements, and then now added to that list is refrigeration systems. It was kind of this large load that had been left out, and after analysis, it made sense to add it in there. Again, the idea is you have to monitor it, and buildings of about 25,000 square feet or larger, and by monitoring it, you can make better decisions on how to make more efficiencies. The next change was updating for dry type distribution transformers. This was less of a direct change and more of a reflection of other things that happened. So the U.S. Department of Energy, they made some changes in their regulations listed there at 10 CFR 461. 90.1 pretty much directly points to those and reprints them in the book, just so that you, as a building designer or engineer or whatever classification you are that you're using the book, you don't have to go to 2 places. You can find those requirements for the transformers. So that was nothing new that was done by the 90.1 committee. It's just a repoint, so you have that information. And then finally, there was some other clarification and updates in section 8. Section 8 doesn't tend to get a lot of movement because it's typically just really primary monitoring, transformers, and receptacles. Those are the 3 major things currently in section 8. Who knows what the future will bring? Next slide, please. There were more changes in lighting, which is section 9. And next slide, please. So of the things that are worth noting, as it's been alluded to, we did a bunch of editorial reorganization in section 9. Previously, we have what's known as the building area method, as well as the space by space method. Those were in 2 different subsections. They're both prescriptive requirements, so they were both put into the same 9.5, which is prescriptive requirements. One is 9.51, one is 9.52. And the idea of this reorganization is matching the rest of the other sections within the standard. And then it was also setting up some future changes that could happen with some parallel structure. There was a lot of clarification and streamlining of lighting control requirements. We do often hear comments and questions of which lighting controls might apply in interior spaces and which will apply in exterior spaces. You'll see a little more about that in a second. We also understand there's some questions of how do you apply the lighting controls. So those were just small clarifications that occurred there as well. A very large change was a new addition of what's known as the simplified method, which I'll show you in the next slide. The interior lighting power density. So the idea here is the standard sets what's called a power density. This is a watts per square foot. You take your building area or your space area, you multiply that by the power density, and that'll give you some value in power. 1,000 watts, 10,000 watts, 40,000 watts, whatever the number is. And that essentially sets your budget for how much power you can use when you design your space. The changes to 9.51, which is the building area method, as well as 9.52, the simplified method, reflect changes in some updating of LED technology, just manufacturers make slightly more efficient fixtures, as well as some small changes into some design practices, as well as some reflectances. Overall, it was about a 5% average reduction in lighting power density values. There were a few that went up because the decision was, well, that space that we think actually is often darker than it is. And so therefore we changed the reflectance value, and that resulted in a new higher lighting power density value. And in some other spaces, we changed it for either newer equipment or other things, and that reduced the number. But overall, about a 5% reduction in interior lighting power densities. And then there were two new major items added: the horticultural lighting requirements and the video conference lighting requirements allowance, which you'll see in a second. Next slide, please. As I mentioned earlier, we added this 9.3, the simplified method. Other sections also have this .3. The idea is you may not want to do a full complex building design and go through all the different prescriptive requirements. So this applies to 3 building types: education, retail, and office. The building has to be 25,000 square feet or less. You could have a mixed use and you apply it accordingly. We think that maybe the design building community might be interested in this approach. You are going to get a lower power density than either in the simplified method, the space by space method, or the building area method. And the reason is that you're also going to have fewer control requirements. So the idea is this is meant to be simplified. It's for a pretty easy standalone building, and you're going to use only a certain amount of power, and you're primarily going to use a lot of occupancy sensors in a lot of the spaces. And the trade-off makes it a more efficient building because you're using a little less power and you don't have to use as many controls. And that's kind of the idea of that simplified term. Next slide, please. So the other major change was the exterior lighting. There are 2 changes here. One is that far right column where we listed the exterior controls. Those controls are not new in any way. They used to be in a section above this table where we described what control features were required. We found that there was some confusion on whether or not which controls were required. And so, for instance, you'll see there in the parking area, it requires B and either D or E. And what that means is 9.4.14b says that when there's available daylight, your exterior lighting should be off. But D actually says that from roughly 11 p.m. to 6 a.m., your parking lot actually should be operating at half power output because basically the stores or the buildings unoccupied and closed, and therefore there should be fewer people in the parking lot, that type of thing. So we put together this column. So none of these control requirements changed from the previous version, but we just tried to make it extremely obvious so people understood which controls apply to which spaces. What did change was, for the first time since 2016, is these power values did lower, and about almost 30% across the board, really stemming from changes in LED and a few changes in some design practices. And again, they hadn't changed since 2016, so that's why there was such a large jump. I don't think in the future we'll see as large of a jump. Next slide, please. Horticultural lighting. So we're seeing the rise of controlled environmental agriculture or horticulture, CEH types of spaces. And the idea is that they are using electric lighting in either greenhouses or other facilities to grow material. And so this sets a requirement. When we often think of lighting, we think of lumens, and the simple rule is lumens are for humans. You can see in that spectral power distribution there in the figure, the lumen is based on the human eye. Plants are very different. They have more and different photoreceptors. So they actually use a different metric called PAR. And then that converts into this other unit of efficacy, which we call photosynthetic photon efficacy, or PPE. And this sets a value of about 1.7 micromoles per joule. And that's it's reasonably achievable with LED lighting. There's some non-LED lighting that you can do it with if you're very careful, but this is just setting a minimum standard for these new types of horticulture spaces. Next slide, please. The other change was that with the rise of video conferencing in hybrid spaces, there are now offices that have really dedicated video conferencing systems. And lighting needs to be a little better there to accommodate the higher quality of camera. Do you want to do some shadows? You want to do some modeling, those type of things. So as a result, this new category of allowance has been added, which is video conferencing, where you get an additional amount of power if you're actually doing a space that is designed for video conferencing. And there's a bunch of requirements around that. You can't just say, oh, I'm doing a Zoom session later from my office, therefore I get a ton more power. Your lighting has to actually be designed to meet video conferencing requirements to achieve that. Overall, those were the major lighting changes. There are definitely some smaller things here and there, but these are the large ones we wanted to bring your attention to. Next slide, please. I'm also going to be discussing the major change in section 10, which is renewable energy. It was added to 10.5 for a prescriptive compliance path. Next slide, please. So as Don mentioned earlier, there's this term on-site, and that matters a lot when we start getting into renewable energy. So what this is it created 10.5.1 and required buildings of a certain size, and you'll see the exceptions down below, to have a certain amount of on-site renewable energy. And they can either meet 0.5 watts per square foot or 1.7 BTUs per square foot. The idea is it could be a PV system. You might have a local hydro facility, maybe in the backyard, you have a stream running through your facility, solar thermal. There's a number of different systems you can have, and this allows you for different options there. What you're going to essentially do is you're going to sum the gross square footage of your building for the first 3 floors. So if you have a gigantic high-rise, this requirement doesn't require every floor. It just requires the first 3. You then to take that area and you multiply it by either of those 2 units, and that's how you determine how much renewable energy you need. There are a number of exceptions. Many of the exceptions are related to some of the needs with photovoltaics. So such as if you had a roof and you were going to have a green roof, we don't really want to counteract some of the green roof aspects and the PV requirement, so you can kind of sidestep that. Obviously, if you are in the shadow of another building, alterations, if you're making a small modification or addition to your building, it would be unfair to say, hey, you have to put all this renewable on site as well. So alterations are exempted from it as well. Next slide, I'll just kind of walk you through kind of how the math works so you can see it. So as I mentioned, the requirement is the gross floor area of the first 3 floors. So in these examples, I kind of gave you 4 examples. You have a single story warehouse, that's the building's 50,000 square feet. Well, 52,000 square feet is the number you're going to multiply it. You got a secondary school that's 2 stories, 26,000 square feet each. Well, hey, that also comes out to 52,000 square feet. So you take those 2. Maybe you have a high rise, that 10-story building. You only have to do the area of the first 3 floors. In each of my examples, they came out to 52,000, just so I could show you the math the same way. So then what you would do is you take that 52,000 square feet, that gross floor area that you have to do, and you multiply it by, in this case, I'm using watts per square foot. So I would need essentially 26,000 watts or 26 kW of on-site renewable to meet this requirement. Next slide, please. As I mentioned, there are some exceptions. These kind of really walk you through it. I've mentioned the green roof. We also have, if your building happens to be in the shadow of another building, and you can demonstrate that through number 3, where you have to demonstrate so many hours between a certain period of time. Because again, we realistically understand that if you're putting PV on the roof and it's completely shadowed by a much taller building off in the distance, that defeats the whole point of that requirement. So those are kind of the highlights. There's a fair amount more nuance to that, but I'd point you back to that section. At this time, I'm going to turn it over to Dick Lord.
Afternoon, everybody. This is Dick Lord. Yeah, I was a past vice chair of the committee. I'm now the chair of the committee. Work for Carrier Corporation. I do a lot of regulatory type of activities, but have been a design mechanical engineer for going on 50 years now. I'm actually sitting in Toronto right now, trying to straighten out Canadian codes. So let's go to the next slide. So, mechanical shows up in a lot of sections. The primary sections where it's at is section 6, where you have all your heating, ventilating, and air conditioning. So that's primarily where we focus most of our effort in the mechanical subcommittee. Section 7 is surface water heating. There's a little bit in section 8, a little bit in section 10, that, some of the power requirements. And then, later on, Mike Tulu will cover energy credits. That's a new field. They're a new option that you have to comply with. Also, you can do the energy budget approach. One of the things we did in 90.1 is a lot of the requirements for small residential light commercial equipment is directly controlled by DOE. So in Appendix F, we documented all those efficiency requirements, because I don't know if any of you guys look at the Federal Register. It's not the easiest document to find things in. So we put all in there as a reference. And then, Appendix G is the performance approach. Appendix H is additional verification and testing. J is a new one that we added, which is performance curve. One of the things we're trying to do, and this is really what the UCB has been working on, is try and make it easier to model. So we put in default curves, and there's some other work we're doing that hopefully will make it even easier as we go along. And then Appendix L is the new mechanical system, what we call TSPR. And Mike will cover that later. So there was a lot of addendum for mechanical systems. Usually there are quite a few. So there were 33 addendum that were released. They got into a lot of new requirements, and we'll kind of dig into those in the next few pages. All right, next slide, please. So, just clarify a few things. There's mandatory requirements. So on a lot of HVAC equipment, the efficiencies are mandatory. You cannot trade them off. You can't say, well, I'm going to put in, better envelope and I'm going to use less efficient HVAC. But you can put in better HVAC and use different envelope, but you have to always meet the minimum requirements for HVAC efficiencies. Like I said, there's some unique requirements for DOE covered products. We'll get into those in a minute. And then there's some products that are regulated by DOE directly. These are the smaller products. There are some products that ASHRAE 90.1 sets the minimums on, but then DOE approves, and we call those preemptive standards. I'll get into those in a little bit. They essentially override any state code that gets implemented. And then we also have prescriptive requirements. There's a lot of prescriptive requirements for mechanical systems. These are requirements like airside economizers, energy recovery, that you can have some options to look at, and there's a bunch of things in there like that. And then we have the new TSPR approach, which again, Mike will cover that. Let's go to the next slide. So this is in all the sections in 90.1, we kind of put these flow charts in there as a guideline. So underneath mechanical, there are quite a few compliance paths. So you can see over there, like Mike was just covering for lighting, there's a simplified approach that's primarily aimed at small office buildings with direct systems, not chill water systems and things like that. And there's a prescriptive path, and there's the alternate compliance path, which gets into the new TSPR, as well as some requirements for data centers and things like that. And then you can always do the energy budget or the Appendix G approaches. So kind of gives you a feel for the section 6 is a little more complicated than section 7 on surface water heating. Next slide. So, we can't go through all the changes for mechanical. There are a lot of changes, especially in efficiency tables. That's one of the things that, with carbon reduction, with energy efficiency, and, considering that HVAC is one of the largest energy users in buildings, there's a lot of focus on efficiency tables, and as well as efficiency metrics. You'll see metrics change quite a bit, and there's more of those coming. Just this year alone, there are 49 DOE rulings in process this to impact HVAC efficiency. So, we have the mandatory requirements that we said and the prescriptive requirements that we said. So let's go to the next slide, please. So, one of the things that happens, there were some updates to tables F1, F2. These are the DOE covered products, as well as some major changes to table 6.8.1 to 6.8.2. These are the typical packaged rooftops, residential split systems, all of the things that show up on a lot of buildings. One of the big changes was a change from SEER to SEER 2, as well as HSPF to HSPF 2. You're going to see more and more of that coming. And we're getting fancier and fancier names. These were kind of simple names that we came up with, but the next ones in 2029, you're going to see some radical changes in names. Also, DOE, one of the things we came up with back in 2010, one of the focuses for HVAC is don't focus on full load efficiency, focus on part load and annualized performance. So we developed the IER approach for commercial unitary products. These are rooftops. That went into effect in 2010. DOE finally adopted it as their primary metric underneath federal law. DOE can only have one primary metric for commercial, so they switched from ER to IER, and IER is a much better metric. It gives you, allows the industry to focus on where the unit's really going to run, which is a part load and things like that. Also, in item number 3, there was an ASHRAE ruling. One of the things we do with DOE is we get into negotiated rulemakings where we all sit down at the table and work through this. So there's one done on VRFs. I'll cover that in a little bit of detail. One of the things that we've added is what we call heat pump chillers. With the focus on carbon reduction, eliminating a fossil fuel, everybody wants to make everything a heat pump. So chillers are very good heat pumps. A lot of people don't realize, a chiller when it's cooling is also heating. So a lot of that heat you can use for heat recovery and things like that. So we added a whole new table, 6.81-16, which covers heat pump chillers. And these are both air cooled, water cooled, heat recovery chillers, and quite a few different metrics. And you'll see a lot more of those in the next few years as people tend to switch from fossil fuels to electrified buildings. There are some changes on transformers, and then there was some work done on DOAS equipment. And that's another product that a lot of people have looked at as, handle your outside air with a separate unit where you put in energy recovery. You need to use that with water source pumps and VRF units, but a lot of people use it with rooftops too and handle the air through a separate system. One of the big things I want to make you aware of, and this is not a 90.1 thing, but we're in the midst of refrigerant changes, and I've been around this industry a long time, so this is my 4th refrigerant change. But this is a big one. U.S. signed the Kigali agreement as of last year. EPA has now released their final rule, phasing out refrigerants like 410A, 134A, 404A, and refrigerants like that. And we have to go to a GWP below 750. So effective January 1 of next year, you're going to see all the refrigerants change in most of the products. VRF will be in 2026. You'll see some chillers going actually in 2024 because a few states adopted earlier, about 12 states. And if any of you guys are interested in that, we can give you some links to the AHRI directory where there's a whole bunch of recorded videos on what's happening with refrigerant change. Next slide, please. So let's talk a little bit about some of the equipment. So single phase, less than 65,000. That's a typical residential unit. Those are controlled directly by DOE. They went from a SEER metric to a SEER 2, and they went from an HSPF for heat pumps to an HSPF 2. What was in there? There was a couple changes to the way the units are rated, the load lines for heat pumps. But one of the bigger changes, as you can see down there in the 4th bullet, is the change in the external static. That's something that, the industry has kind of been on the low side for us. Statics are in the 0.1, 0.2 for residential equipment, and they raised them up to a 0.5. So, that increases your fan power, it decreases your efficiency. They also changed some of the load lines for the heat pumps and address the cold climates. We hear a lot about cold climate heat pumps. I'm actually sitting in Canada right now, so we were talking about that today. And, as to where they're going. For the three-phase, so all of those changes went into effect on 1/1/2023, and that's a mandatory change. We no longer can sell SEER products. Everything had to go to SEER 2 and HSPF2. So that really was a huge change for the industry. Three-phase, typically what we like to try and do, they're controlled directly by ASHRAE. So we updated the efficiencies, but DOE has to approve it, and they didn't approve it in time. So really, three-phase does not go into effect until January 1, 2025 for all equipment. But in 90.1, they showed effective as 1/1/2023. So technically, a state can make it effective on new construction as of 1/1/2023. A little bit confusing, so just pay attention to that. But typically, these requirements override any state requirement. Go to the next slide, please. So I put this chart in, and you cannot find this in 90.1. This is your handy dandy converter chart that says, here's what SEER 2 is relative to SEER. So basically SEER 2, if you look at an air-cooled package unit, it decreased the efficiency by 5%. Now, when you go and you look at the new efficiencies, they're actually higher because at the same time we made the change from SEER to SEER 2, we increased the efficiency. So, we went to a 15 SEER level, but that's actually a 14.3 when you do the D rate for the static. So I thought that might be useful to you to compare it because not everybody has all the new numbers out there for you to use. Next slide, please. So this is kind of a detailed chart. I put that in there more for a reference for you guys. Like in the past, we have regional requirements for single phase equipment. And I showed you before 1/1/23, after 1/1/23, and then you have a national number, a southern number, and a southwest number. And typically in the southern regions, the values are higher. In the northern region, the values are lower because they tend to be more dominated by heating and things like that. So it's in there as a reference for you guys so you know what some of those values are and what you have to be in compliance. Next slide. So in commercial, for a long time, we had worked on the IER, as I mentioned earlier. So we converted from an IPLV, which was a really old metric, to an IER. And gradually over time, the industries adopted that metric, and DOE now made it effective 2018. When we made it effective 2018, they adopted the ASHRAE numbers, but then we agreed to raise the numbers in January 1, 2023. So like the residential numbers, the IER values went up for the air-cooled products. One thing I'll note too, and I put this at the bottom, we just completed another ASHRAE ruling. Not like we don't have enough to do, but the new ruling is a radical change. So in 2029, you're going to see all new metrics for commercial rooftops. It'll be a thing called IVEC, integrated ventilating energy cooling efficient. And then an IVHE, which is very much like an HSPF, which is an annualized metric for heating. Those are radical changes. The metrics now will include economizers in them, includes ventilation in them, includes crankless heater power in them. So a lot of changes, and then significant improvements in efficiency again in 2029, anywhere from 16 to 36%. So next slide, please. So here's a detailed chart on the commercial units. It shows what these values went to. So these are the ones that went into effect on 1/1/2023. You can see the efficiency levels ranging from 8 to 16% in that range and where they go on those. Next slide, please. And then the heat pumps, the same thing, a lot of focus on heat pumps. We're seeing a lot of new heat pump products coming out, cold climate heat pumps. You'll probably see in the we just finished it, but a dual fuel heat pump metric that'll be coming out in a new standard coming out of the ASHRAE, and a similar one being worked on for commercial. So stay tuned for those as they come through. Next slide, please. So a lot of other changes on VRF. There was an ASRAC negotiation. One of the things they looked at on VRF is, they saw that these units didn't have very good sensible heat factors. So they put a minimum requirements of sensible heat factor at 100%, and 75% if the unit doesn't meet that criteria, in other words, doesn't have enough latent capacity, then there's some adjustments they have to do to the rating. So it kind of forced a re-looking at the ratings. That resulted in about a 4.2 to a 6.7% drop in the ER. Keeping in mind, ER is not really the best metric, and the IER is a better representation of the performance. And what they did is they did not adjust the IER. Manufacturers basically said, you know, we can cover that change in the rating metrics, and basically equivalent to about a 12% improvement in the minimum efficiency for VRF. So just to let you know on that. Next slide, please. All right, a couple other things we did. We added a table, like I said, on heat pump chillers. You know, that's per ASHRAE 550, 590. It's a little bit confusing. There are multiple metrics, one at 105, 120, and 140 degree water temperature. Any of you guys designing heat pump chillers, you know, it's not like a boiler. Don't run your water temperatures up. For every degree you drop that water temperature, you got about a 2% improvement in efficiency. You know, look at things like temperature reset and things like that. So there's a lot of education and training we have to do on heat pump chillers. There's hybrid heat pump chillers going in with air cooled to water cooled and water cooled to water. So a lot of things you can do on that. Like I said, we changed the commercial dry transformers. That was just an update on the efficiencies. Did some work on DOAS equipment, you know, with a new metric. It went from ISMRE to ISMRE2. You know, that's a moisture removal efficiency. So they went through the crosswalk and they've implemented some of the changes. We didn't do a lot of changes to furnaces as part of the ASHRAE negotiation. We went from 80 to 81% thermal efficiency. May sound like a little bit, but one of the things we're very careful on commercial equipment is not getting into condensing, because condensate brings along a lot of acids and freeze problems. And, you know, a lot of the studies, we said it didn't really save a lot of energy because of the increased static, you know, because fans run all the time on commercial equipment. So there's a clean up to table 5 that just covered furnace efficiencies. Next slide, please. And then a lot of other changes, some boiler efficiency improvements requiring 90% condensing furnaces on larger boilers, some updates to demand ventilation. Demand ventilation is kind of an important thing these days, especially considering the typical office building these days is 50% occupied. So it's really good to implement demand ventilation even beyond code, because it's a real good energy saver. We did some work on small unit setback, just clarifying some things that have to do with that. You're going to see more changes coming on setback for thermostats with automatic demand limiting and some new standards like 1380 for residential. And there's a new 1390 coming up for commercial. Some optimal start requirements for residential spaces where you don't need it. Some updates on garage ventilation and then shaft ventilation dampers. Next slide, please. And then we clarified some things on chiller freeze protection. One of the things that was kind of an easy way to get out of standards requirement is say, well, I have a little bit of glycol in my unit, especially an air-cooled chiller in a colder climate zones 4 and above. So we clarified that you can still be certified. You just prove performance with water in the unit. That's accepted by ASHRAE. And then we also did some adjustments to K-Adjust. And if you guys aren't familiar with K-Adjust, that's for centrifugals. A lot of times the centrifugal in a cold climate will not run at standard rating conditions. So we came up a long time ago with this K-Adjust, and there's actually a tool available that can calculate that for you because it's got a lot of numbers in the equation. Some updates on service water insulation, some simplified billing updates. One of the things is a lot of focus in the industry now on fans. So we added a ceiling fan efficiency requirement. You'll also see more changes coming in the next round of 90.1 on supply fans for the indoor space, as well as fan efficiency. First time we added this on compressed air, that was in Title 24, and we kind of picked up some of the stuff that did in Title 24, and compressed air can be a pretty big energy user in buildings. So next slide, please. And then some updates on dehumidification control. One of the things ASHRAE 62 put in is an off-hour 60-degree of dew point to kind of prevent mold issues. So, you know, 62 does not really focus on energy. We focus on energy. So we went in and clarified things so that you're not wasting a lot of energy trying to meet that. There's some requirements on service water heating control. And guideline 36, excuse me, guideline 36 is a really good document. And It's been developed over the years to give you recommended control sequences for operating of units, multiple chillers, cooling towers, VAV systems. So we reference that guideline. You're going to see more and more of that. It's being picked up by other standards like Title 24 and things like that. So really good document to start with your control sequences. Some updates on elevator requirements, trying to get into the laying and fan power metrics, as well as the minimum efficiency for elevators. Next slide, please. And then a couple more things, ERV bypass. One of the things, ERVs are a great way to save energy, especially if you're bringing in a lot of outside air. So there are prescriptive or tables in 90.1 covering that. But ERVs tend to have very high airside pressure drop because they have fairly thick heat transfer medias. And we clarified what you have to do with bypass. So when you're going into economizer mode or the energy recovery is not working when temperature differences are low, we put some requirements in there to clarify what you do with bypass dampers. And then a little bit more clarification than the exhaust air energy recovery metrics, some DOAS exemption, and then some further clarifications and updates on hospital heat recovery. I think that's a huge opportunity for a lot of buildings because a lot of commercial buildings have simultaneous heating and cooling, and especially for large chillers, VRF, and water source heat pump. It's a great way to reuse energy inside a building. Next slide. And then some economizer trade-offs. We updated the table that says if you're in, say, an unattainment area where you really don't want to bring in outside air, here's what you have to do for efficiency. So you have to go to higher efficiency. We did expand the economizer requirements down to 33,000. That's only for units that are outside a building. It's not a unit inside the building. So if you got a rooftop, you now have to have economizers down to 33,000. They're a great energy saver. So encourage you guys to do those. Some small fan efficiencies, FEI, this is fan efficiency, and then occupied standby. This is kind of where I've got a conference room. It's an occupied mode, but there's nobody in there. So you can go what you call occupied standby. So you reset your thermostats, you turn off your ventilation. Great way to save energy again. Next slide. And then some final thing is some large capacity service water heating requirements, just defining some further efficiency improvements on those and where they go on those. I think that's the last slide. Go one more, please. Yep. So I'll turn it over to Mike Toulouse. He'll now cover our TSPR, which is a mechanical thing, but Mike has developed a lot of this, so he'll give you good insight into that.
Okay, thank you, Dick. I'm Michael Toulouse. I'm an advisor at Pacific Northwest National Lab, and I've been active in 90.1 for a long time here now, going on 15 plus years. And so I'm going to talk to you about two new features in 90.1 that were added into the 2022 version. Mechanical TSPR, or total system performance ratio, and I'm also going to go through energy credits. And they didn't give me a lot of time for this, so I'm going to go through them pretty quickly here. As Dick's explained, TSPR is a new optional performance pathway in Section 6 for HVAC systems. It sits there as an alternative to the prescriptive path. Next slide. And really the idea of this new performance-based HVAC path is really similar to the Appendix C performance path that has been in the 90.1 for a long time for the building envelope. So the intent is to allow a project to look at the HVAC system as a complete system, not as individual components the way the prescriptive path does. So you model your proposed HVAC system, and it gets compared to the performance of a good system, good in quotes, good system for your building type. And then we compare the two, and if the performance of your proposed design is better than the target system, then you've demonstrated compliance. And the nice part about this is it allows a team to take trade-offs by maybe say you have a higher efficiency piece of equipment, a higher efficiency boiler or chiller. You can get some credit for that if you have trouble, say, meeting the fan power limits, or You have a space in your building that's challenging to get a full air side economizer. You know, it allows for some opportunities for trade-offs that the prescriptive path doesn't allow you. Next slide. So what is TSPR? So the metric that we selected for TSPR is the ratio of your project's heating and cooling loads that are required to be delivered by the HVAC system divided by the annual HVAC operating input. And we say input for a very specific reason. So the denominator of TSPR can be cost, it could be energy cost, it could be site energy, it could be source energy, it could be carbon emissions. So the nice thing about TSPR is it does not have to be limited to just a cost analysis. A jurisdiction can adopt it and decide what metric makes sense for their jurisdiction to evaluate. The other interesting feature about the TSPR metric is we set it up, in case you haven't noticed, so that the input is on the denominator. So it's similar to a metric like COP or EER, where a more efficient design is going to have a higher TSPR value. So that way it's aligned with the other HVAC metrics so that, you know, as you see that your TSPR gets bigger and bigger, you know that it means your system is more efficient than your target. The other nice feature about TSPR is, unlike the prescriptive path, because it's a performance-based approach, you get credit for part load performance of your equipment. So as equipment becomes better and more efficient, not just at full load, but at part load, an optional pathway like this allows projects to claim credit for those without having to do a whole building energy model, which would be really time consuming. Next slide. So this is just for information. This the TSPR method that's set up in 90.1 aligns with the modeling protocols in Appendix G. So we have a reference system that's aligned with the Appendix G reference systems that use performance criteria that's sort of equivalent to the 2004 version of the standard. We have target systems that are set up that are based on the performance of the current version of the standard. And then the ratio of those two is what we call a mechanical performance factor. And that's what we use to then compare against the TSPR of a proposed design. All of this is handled automatically in software, so users of TSPR don't have to worry about this. But it's helpful to just understand how the TSPR method is set up. Next slide. This just gives you an idea of the different reference and target systems that TSPR looks at. Currently, TSPR is only available for office, retail, education, and hotel multifamily building types. Other building types like healthcare, there's really too much complexity in the HVAC system, and really projects that need to do trade-offs with more complex systems really need to be using a whole building trade-off. So TSPR is really intended for buildings with simple systems, where doing a whole building energy model might be really cost prohibitive. It allows you to do a very simple trade-off approach. And as you can see here, you know, for larger buildings like the office, a large office, you know, we're going to have a VAV target system. If we're talking about smaller buildings, we're talking about packaged equipment as the good design target system. So there's nothing too aggressive here. You know, it's reasonable assumptions have gone into the definition of good practice. Next slide. And then finally, the compliance tool. So PNNL has created a TSPR compliance tool. that will be available for anyone to use to do your TSPR calculations. It's based on the language that's in the rule set in 90.1. And it's designed around, you describe your building using a simplified block model approach, where you just use a few inputs to describe the size of the building, the different occupancy types that you have. You put in some inputs to describe, your window to wall ratio, the envelope assemblies that you have. The piloting that we've done of the TSPR tool has gotten really good reviews from designers. They really like the interface. It's easy to use for them. And so we're really excited to sort of see this rolled out into 90.1. Next slide. I think I've got one more here on TSPR. Nope, that was all for TSPR. So that was the quick high-level overview, and I'll jump into energy credits so we stay on target here. Next slide. So for those of you that are familiar with the IECC, you're probably familiar with the idea of energy credits. So this is the first time energy credits has been introduced into 90.1. And really the idea is energy credits sit as an extension of the prescriptive requirements in the standard. And it provides an opportunity for additional energy efficiency beyond the base prescriptive requirements that are flexible and allow design teams to pick the credits that are appropriate and applicable to their project. And we know that every project's different, so the energy credits really introduce a level of flexibility in achieving additional energy efficiency beyond base prescriptive requirements. So next slide. So the benefits of this energy efficiency credit approach, really the first one is flexibility. The prescriptive path, trying to increase the efficiency of the prescriptive path is challenging because every building has to meet those requirements. And so credits allows you to pick and choose additional efficiency options that are appropriate for your project and your climate zone. You can mix and match different options across different systems, whether it's lighting or HVAC or envelope, to meet the target number of credits. The other nice thing about the energy credits approach is we can include credits that aren't necessarily cost effective for every building. We know that can be challenging, and that there are efficiency features that a building owner wants in their building that may not be strictly cost effective, but for, it's appropriate for sustainability goals that they have or other goals that they might have. And so we can include those types of credits in here. And because they're not mandatory or prescriptively required for every building, they don't necessarily have to be cost effective. And credits lays the groundwork for future performance trade-offs and targets for small, simple buildings. Next slide. So who has to do energy credits? Pretty much, if you've got a new building or you're doing infill construction or an addition that's larger than 2,000 square feet, you have to meet the energy credit requirements. If you're doing what we call a substantial alteration, where you're replacing any two of the HVAC system and lighting in the envelope, the energy credits requirements kick in for projects over 5,000 square feet. Similar to the standard, things that are excluded from credits, equipment in utility buildings, the industrial portions of a factory building. Obviously, we can't apply credits to those types of areas within a building. They just don't have the ability and the ease of applying the credits. The credit thresholds are established by building type and climate zone. So there's different requirements depending on your building type, your climate zone. And then there are different ways that you can achieve credits. All of the credits have a sort of a base value, and you can either just earn that credit value. Certain credits allow you to adjust the number of credits you earn, so you can earn more than the base value of credit. So for example, if you're getting credits for improved HVAC system performance, there's a minimum level of performance, increased performance you need to meet. But if you go beyond that, there's a formula where you can calculate additional credits that you might be able to earn. And then there's some other credits where you do a calculation. So for example, there's a credit for improved envelope performance that uses the Appendix C calculation method. So there's different ways that the credits get calculated. And I'll talk a little bit. I've got a slide on how this is going to be all handled in CommCheck in a little bit here. So next slide. So pretty much across the board for most building types, in most climate zones, you're required to earn anywhere from 42 to 50 credits. And we've set up the credits so that each credit represents 0.1% of whole building energy cost. And the reason we did that is because by basing one credit on 0.1% of savings, it allows us to bring in more credits that have maybe a small impact on overall energy performance, but it allows us to have more choices. And so it increases the flexibility and allows us to have as broad a list of credit measures as possible. So the current targets of around 50 points, 50 credit points, is designed to achieve an additional 5% reduction in building energy cost, or a 5% improvement in overall building efficiency. There are credits for renewables that you can get. And then other building types have a reduced requirement because, if you fall outside of the building types that we have building prototypes for, it may be challenging to understand, apply the credit requirements. So there's a reduced requirement for those building types. Next slide. So there are over 30 energy efficiency measures included in the credit section, covering envelope, HVAC, service water heating, additional on-site renewable energy beyond the new prescriptive requirements. There's also credits for peak load management. So for designing a building so that the systems in the building can actively participate in demand response program, or have automatic shading in response to signals, or include storage. So there's a lot of flexibility in the credit section that we've built in as a starting point. Next slide. So the energy credits requirements are the new version of CommCheck that's being developed for 90.1-2022 will include its own section on energy credits now. And the CommCheck team is working to integrate the CommCheck inputs so that many of the energy credits that would be based on the CommCheck inputs will automatically calculate the number of credits that you potentially earn. So for example, when you put all your lighting fixtures in and document your lighting system, lighting power requirements, CommCheck will automatically determine whether you earn credits under the reduced lighting power credit. So the CommCheck team is working hard to make sure that credits are easily documented within the CommCheck environment. It'll all be a separate section within there, which is, we've heard from users, is an important feature that they they want to have there. Next slide. So in summary on energy credits, 5% additional efficiency gained in the 90.1-2022, 32 measures. It is important to note that cost effectiveness was considered in developing the energy credits proposal. For each building type, there was a cost-effective package of credits that was developed. A lot of work went into that. And as a result of that work, there's also the ability to use some of the load management credits to offset efficiency requirements in certain cases. But that was an important part. And then the credits is going to be fully integrated into ComCheck so that it will be compliance will be easily documented, and code officials will have a fairly easy time documenting that the credits are being met. So with that, I will turn it back over. I'm not sure who's next. Oh, Mike Rosenberg's next.
Oh, thanks, Michael. Yeah, for our next speaker, we have a video that was recorded ahead of time. So I'm gonna stop sharing my screen here and I will share that video with you all.
Hello, I'm Michael Rosenberg, Manager of the Building Energy Codes Program at Pacific Northwest National Laboratory. Today I'm going to talk about updates to the whole building performance paths that are included in the 2022 edition of Standard 90.1. I want to start off with a little background on the performance paths in Standard 90.1. As many of you are probably aware, the standard includes two whole building performance paths, the energy cost budget method and the performance rating method, often referred to by its location in the standard Appendix G. The two methods are similar in that they both compare the energy cost of a proposed design to the energy cost of a baseline or reference building design, but there's some important differences in how the baseline is determined. Under ECB, the baseline includes basically the same systems and components as in the proposed design. For example, a small office building in Climate Zone 2, designed with wood-framed walls and a packaged rooftop gas furnace, includes the same wood-framed walls and packaged furnace in the baseline, with the U factor of the walls and the efficiency of the furnace set at the prescriptive values of the 2022 standard. If the energy cost of the proposed design is less than the energy cost of the baseline design, the building complies. We refer to this as a dependent baseline approach. It's a bit different in Appendix G. The baseline systems and components in Appendix G are based on the architectural program of the building and the climate zone the building is located in. In other words, it's more independent of the proposed building design. For example, under Appendix G, the baseline for the small office I just described would not have wood-framed walls and a gas furnace. Instead, the baseline for all small offices in Climate Zone 2 have steel-framed walls and are served by packaged rooftop heat pump. Also, unlike ECB, the efficiency values in the Appendix G baseline are set at a level approximately equal to the efficiency of the 2004 version of Standard 90.1 instead of the current version of the standard. Because of that, the proposed building energy cost needs to be substantially lower than the baseline energy cost in order for the building to comply under Appendix G. As each new edition of the standard improves and the baseline remains stable at the level of the 2004 standard, the compliance margin between the proposed energy cost and the baseline energy cost increases. Standard 90.1-2022 included 33 addenda that impact the two performance paths in the standard. 6 of those addenda impact the energy cost budget method, 13 of them impact the performance rating method, and 14 impact both energy cost budget and performance rating method. I'm not going to talk about all of those today. I'm just going to highlight what we felt were the most impactful ones. The first addendum I want to talk about is Addendum BV, and that's updates to the building performance factors. Building performance factors represent the improvement in regulated energy use between each version of 90.1 and the 2004 stable baseline. So as the standard gets more stringent, the BPFs get lower. A BPF of 1 represents a building compliant with the 2004 version of the standard, and a BPF of 0 represents a zero energy cost building. There was a change in the way BPFs were calculated this cycle. Instead of just comparing prototype buildings compliant with the 2022 version of the standard to prototype buildings compliant with the 2004 version, it compared 2022 prototypes to a more true Appendix G baseline. So instead of just looking at 2004 prototypes, the baseline is now following the rules of Appendix G, and it's really a more accurate way of developing BPFs. And that resulted, it had a pretty impactful change on the BPFs. Many of them became less stringent than they were in 2019. So even though the standard improved in stringency, the BPFs themselves got less stringent. And that's demonstrated by the two tables in front of you. The upper table are the BPFs that were in the 2019 version of the standard, and the lower table, the BPFs that are in the 2022 version of the standard. The heat map represents, the red colors in the heat map represent BPFs that have gotten less stringent, and the green represent those that have gotten more stringent. So you can see some went up, some went down, but probably more got less stringent than improved in stringency. So really that's a pretty big difference. And for those of you that are not familiar with this table, the columns represent the different climate zones, and the rows different building types. Addendum AF includes some clarifications to the way lighting power is calculated, particularly in the baseline building. There was, when the space types are not known in a building, for example, when you have a core and shell and tenant improvements have not yet been made, you may not know what the space types will be in that future building. Appendix G has some rules that says you can assume that the lighting power in your proposed design will be equal to the prescriptive requirements that are in the current version of the standard. But it wasn't clear which approach that you should use for calculating those. So the lighting section 9 includes a building area method and a space by space method. This addendum clarifies that you need to use the space by space method if you do know what the space types are in a building that's not completed yet, or excuse me, in spaces that are not completed yet. And if you don't know what the space makeup of that building, of that area of that building will be, you can use the building area method. And whichever one you use in the proposed design, you have to use in the baseline as well. It also makes a couple of other changes to lighting, or clarifications to lighting. It establishes retail display lighting adder in the baseline. So if you have retail display lighting, that's an adder in section 9. You get to put that adder in your baseline, but only up to the prescriptive limits. Another change is for what are called non-tradable surfaces in lighting, or non-tradable exterior surfaces. Those include building facades and lighting that is over doorways. These are the kinds of allowances for exterior lighting that we sometimes refer to as use it or lose it. You get to use that lighting. If you have facade lighting, you get to take advantage of that up to a certain amount. But if you don't have facade lighting, you don't get to trade that off and put more lighting somewhere else, for example. So it makes it clear that these non-tradable surfaces are use it or lose it in the analysis. The next one, addendum BD, chiller curves. Prior to this addendum, there was really no direction given on how to represent the part load performance of your baseline or your proposed building chillers. There was an IPLV, or part load performance requirement, but really to simulate that part load, in most simulation programs, it requires a series of 3 part load performance curves. And it was very inconsistently implemented in models because there was no more direction than just a single IPLV. So in this addendum, they're introduced a new appendix that has a series of part load performance curves for all the chiller types and efficiency values that are in the body of section 6, the HVAC section. So for example, if you have a centrifugal chiller in your building, a water-cooled centrifugal chiller, you can go to that appendix, look at the size, and it will provide the 3 curves that are needed to implement the part load performance in most simulation programs. And the same thing for the baseline. It provides a set of curves for the different values that are required in the baseline. And those curves are optional in your proposed building design because you can always go to a manufacturer and get equipment curves for the actual chillers, or not always. You can often go to a manufacturer and get the exact part load performance curves for that chiller. But if they're not available, these curves provide a default. But in the baseline, they're required. Since the baseline is not based on a particular piece of equipment, just on an IPLV rating, you now have to use these part load performance curves in your baseline design. And the curves are provided in both SI and IP units, so they're usable in a variety of simulation programs. And for those modelers out there, it uses the modeling approach for chillers that is based on entering condenser water temperature as opposed to leaving condenser water temperature. And the reason that was chosen is because entering condenser water temperature is an approach in most simulation programs where leaving condensing water temperature is not available in some of them. Addendum CH introduced an informative appendix that, and by informative appendix, it means that it's optional, but this appendix now has criteria and instructions for using metrics other than energy cost with the performance rating method. So one of the problems that states and jurisdictions have had with energy cost is that it doesn't support the policy goals that many of them have for electrification and decarbonization. Often natural gas is less expensive than electricity in many jurisdictions, if not most in the country. So using energy cost would discourage electrification. So users of the standard have asked for some alternatives, and that's why this was provided. So these alternatives are provided in this appendix with a series of building performance factor tables, alternate tables to those that we discussed previously. And there are tables that are applicable to site energy, source energy, and emissions. And those tables are based on national average emission values. For example, just like the tables in the main body of the standard, the BPF tables are based on national average energy costs. But we know that energy costs and emission values vary in different regions. Different e-grid regions, different parts of the country have different costs for electricity and natural gas. So this addendum also introduced an approach for customizing building performance factors. So it provides some equations, and you can put in either your conversion factors for emissions, your pounds of CO2 per kilowatt hour and pounds of CO2 per therm, or you can put in your dollars per kilowatt hour or dollars per therm, and then generate a set of building performance factor tables that are more specific for your region. And then the CK and CP deal with renewable energy systems. In 2022, for the first time, there are prescriptive requirements for on-site renewable energy systems in the standard. These 2 addenda provide instructions for how the renewable energy systems in a proposed design should be modeled for both ECB and Appendix G. And for the baseline, renewable energy systems is handled differently for each. For Appendix G, there's no renewable energy system modeled in the baseline. For ECB, there's 2 approaches. If your proposed building includes renewable energy, the baseline uses the same type and configuration. If there's no renewable energy in your proposed building, a default PV system is modeled in the baseline. And the defaults are configured to be consistent with NREL's PV Watts software. Addendum U addressed 2 topics in the energy cost budget method. The first was really just a cleanup. It rearranged and moved around how the baseline HVAC equipment capacity requirements are represented in the standard. The second one was a little bit more impactful. It's how economizers are modeled in the baseline. Previously, you modeled an airside economizer in the baseline if there was an airside economizer in your proposed building design, and a fluid economizer in the baseline if there was a fluid economizer in your proposed design. Now, regardless of what is in your proposed design, you model an air side economizer in the baseline. This helped to make the modeling more consistent between different buildings. Addendum AB addresses how baseline systems are selected in the performance rating method. It was a major reorganization of the language that describes how to select those baseline systems. The intent is the same as it was before this change, but it really clarifies things. It makes it clear that there are 6 distinct building area types that are used to select the baseline HVAC system: residential building area type, public assembly, heated only storage, retail, hospitals, and other non-residential. It also added a new term, residential associated HVAC zones. And that term is used to describe non-residential spaces that are in residential buildings. So it helps to clarify proper selection of the HVAC system for those spaces. And those spaces are typically corridors, stairwells, lobbies, and the kinds of spaces that support residential buildings. Addendum CO addresses how retrofits are handled in the PRM. Prior to this addendum, retrofits often had a very difficult time complying with Appendix G or the PRM because they were held to the same standard as new construction. So this addendum breaks retrofits up into 2 categories: substantial alterations and minor alterations. For substantial alterations means that 2 of the 3 main building systems, the building envelope, the lighting system, or the mechanical systems, are substantially altered. So if you make improvements to 2 of the 3 systems, it becomes a substantial alteration. It then needs to follow the same rules as a new building, except the building performance factors are relaxed by 5%. For those minor alterations, it takes a different approach. It's more like the energy cost budget approach now. So for areas of your building that are not altered, the baseline are the existing building conditions. So you're not rewarded or penalized for not making improvements in the existing building. For those areas of the building that you are altering, the baseline is set at the prescriptive requirements for that alteration. So for example, if you open up a wall cavity, the prescriptive requirement is that you fill that wall cavity with insulation. You don't need to meet the new building U factor requirements. You just need to fill that cavity. So the baseline for a wall that you've opened up now is the prescriptive requirement. It only has to have that wall cavity filled. And along with that, the building performance factors for those minor alterations are set at 1. So in effect, it's using the same approach as the energy cost budget method does for those minor alterations. And then it also clarifies that when you're modeling an existing building with an addition, the BPFs are based on an area weighted calculation of those 2. Addendum CR introduces an envelope backstop to both ECB and Appendix G. One of the problems that stakeholders, or one of the concerns that stakeholders have with the whole building performance paths, is that it allows trade-offs between long life components like the building envelope and shorter life components like lighting or the HVAC systems. So this is an attempt to put a backstop on the trade-offs allowed for the envelope, so a limit on how bad the envelope can be, how much you can trade off. And to do this, it uses the 90.1 envelope trade-off method. That method allows trade-offs within the envelope system. So for example, you could have more roof insulation and less wall insulation. And it uses the ComCheck software to establish those trade-offs. And this applies only to new construction projects. When you use the envelope trade-off approach for standard compliance, the proposed building envelope has to have an envelope performance factor that is no worse than the envelope performance factor of a baseline building. The backstop is a little bit different. Instead of being no less than the baseline envelope performance factor, there's a certain amount that it could be worse than the baseline envelope performance factor. And that amount is 15% for residential occupancies and 7% for all other building types. And the way those numbers were developed is that analysis was done based on a 70% window to wall ratio. So basically, a residential occupancy with 70% window to wall ratio with all the components meeting the prescriptive values will have an envelope performance factor about 15% worse than the baseline. And similarly, for all other occupancies, a 70% window to wall ratio will result in an envelope performance factor about 7% worse than the baseline. So it's really not that stringent of a backstop, but it is the first time that a backstop has been introduced into the standard. This slide just shows a screenshot of the CommCheck software inputs. For those of you that have used CommCheck before, there is no difference in how CommCheck is used for this envelope backstop. You just enter information like you normally do for compliance, and then it will tell you whether or not you've met the backstop. These next two slides list the remaining and what I consider the less impactful addenda to ECB and Appendix G. I'm not going to go through them all because of time limitations, but I wanted them to be listed for your reference. If you're interested in the details of any of these, you simply go to the ASHRAE website and you can download them. They'll be in strikeout underlined format so you can easily see what's changed. Also, each one includes a foreword that explains the purpose of each addendum. Anyway, thanks for listening, and I'll turn this over to the next speaker.
Great, thanks so much. So that was our last speaker, and now we have about 20 minutes or so to do a Q&A. See that we had a lot of good questions come in, and already have some answers in the Q&A function there, but I think it might be nice to also go through some of those and talk through them with our panelists. Rose, did you want to help facilitate and ask some of those questions to everybody?
Yes, happy to do that. Thanks first to all of our panelists. Great presentations. Really appreciate your time and effort for the webinar today. The panelists did a great job answering most of the questions, if not all of the questions, as they were coming in, but I have selected several that we had noted to talk about a little more. And I'm going to start with some that came in towards the beginning that were related to cool roof and wall. And the first question related to that was, has the cost effectiveness of cool roof requirements in US climate zones been established? Len, do you want to take that one?
Yeah, so I'm not sure how everyone realizes. So 90.1 has a sort of fairly rigorous cost effectiveness criteria for anything, whether it's a cool roof or a chiller or a light switch. So within that sort of process, we basically look at the first cost of a various energy efficiency measure, or the first cost premium. And then we look at it over the life cycle of that product. And as Michael alluded to, some components last many years, like windows are around for years, and some things are shorter. Roof equipment, light switches. In the case of roofs, I think we use 25 years or something. But anyway, so the current criteria for cool roofs was vetted or validated a couple code cycles ago, and it hasn't changed. So the answer is yes, cool roofs are in the minds of 90.1 deemed to be cost effective, up through climate zone, I think 4 in the current standard. And we haven't really revisited that. We've been looking at other things like PV and green roofs and cool walls, but for cool walls, we would do the same thing. We would look at the cost premium to go to sort of a higher quality paint or high albedo paint. We look at it in the climate zone and see if it's cost effective, and maybe it is cost effective in climate zones, 1 or 2. Preliminary research shows that it is indeed cost effective up to climate zone 2.
Okay, thanks. That's what I was just going to ask you. Perfect. We also had a couple questions related to thermal bridging. When you increase the insulation, you have an issue of condensation. How does the code address this issue? We don't want mold and mildew in the building.
So We have some language in the standard that says this is not a moisture standard, right? We know that there are, when you start adding insulation in the wrong place and you start adding vapor barriers in the wrong place, you could sort of have problems. However, there's a whole nother ASHRAE standard that deals with moisture and condensation. So we don't really address that. 90.1, not that we're ignoring it, but the place is not 90.1 for that. And we can have a whole issue of condensation, but yes, it's a legitimate concern. But there are all the assemblies that we propose, there are strategies where you won't have condensation happening. And of course, it does depend on the type of building. Is your building humidified? What climate zone are you in? And how airtight the building is, how permeable the insulation is it hydrophobic? Is it, hydrophilic, stuff like that. So there's a lot of issues that go into where your wall is going to condense. So I don't know if that answers your question, but it's sort of where we stand.
Thanks, Len. And the last one related to thermal bridging, I know you answered, but if you could answer for everyone. The question was, is there an allowance for thermal bridging in areas with high seismic requirements?
Oh, yeah, so I did answer that in the chat. Basically, we did talk about this, but we came to the conclusion that it's best left up to the engineer of record and the architect of record. That there's so many different seismic classes, there's zones, there's building importance factors, that there's no way that we could write requirements for different ones. We do know that all these solutions work in high seismic zones. They're structurally sound. So it's really just going to be project specific. And it might be a little bit more difficult for buildings, in high seismic zones. But everything's more difficult for buildings in high seismic zones.
Fair enough. Thanks, Len. All right, moving on. We had several questions as well that came in during Dick's presentation that also were answered, but I thought it might be helpful for Dick or anyone else to maybe address the question about explaining when 90.1 becomes the path to compliance rather than the IECC. Anyone want to take that?
Well, yeah, it depends on what your, this is Dick, yeah, it depends on what your state has adopted. If your state has adopted the IECC would be the path, but in the IECC, there is a path to go back to 90.1. Now, if it's a federally preempted product, it preempts both IECC and ASHRAE 90.1. So if, DOE changes efficiency during the cycle and it goes into effect, DOE preempts everything.
Thank you. There also was a question.
I think Mike might want to add something. Yeah,
I was going to add to that. There are a couple of states. Can you hear me?
Yes.
While 90.1 is an allowed option in the IECC, there's also a couple of states that have 90.1 directly as their code, like Oregon and Alabama, two that come to mind right away.
Yeah, you go directly to those, and and then there's also a few states like California that have, and Washington that have their own code. So, they're neither one of those.
Great, thanks. Another question that came up was, are chiller performance curves available for heat pump chillers and water source heat pumps?
I'll take that one. They're certainly available. You might be able to get them from a manufacturer. We have not included them in standard 90.1 yet. It was a big lift for us to get the standard chillers that we got in there already, and we would like to in the future expand that to different types of chillers, heat pumps, DX equipment, and other equipment. And hopefully we'll get a little bit more of that in the 2025 standard, but for now they're not included in there.
Mike, the other thing maybe to add to that is a water-to-water chiller is really a heat pump. It cools and heats at the same time. So it's within the range of the curves. You can get the heat rejection out of it. But, like an air-to-water heat pump, yeah, we don't have those curves yet.
Okay, great. Kind of a miscellaneous question that came in. asking whether there are any updates on the software requirements for 179D energy modeling tools.
There have been some updates, and I stuck a link in the question and answer that shows the latest list of approved software for 179D.
Okay, great. So people can refer to that link for those details. Does the standard lay down a path for grid interactive buildings to unlock demand flexibility from buildings?
It does not yet. You know, that's something we're talking about right now. I know there was some requirements for that put in the IECC that'll be coming out at the end of this year, but for commercial, we don't have grid interaction in there. Is there any more you want to add on that, or?
Well, there are load management credits and energy storage credits in the energy credits. So to that extent, it is handled, but there are no mandatory requirements or even straight prescriptive requirements yet. But there are optional credits for HVAC load management, lighting load management, automatic shading load management, things like that.
There's a couple things coming. There's a standard out that ASHRAE has put out as 1380. That's for the residential, demand interface. There's a new one called 1390 coming that we're working on right now. So stay tuned. There's a lot of stuff coming in grid interactions, the smart grid interface.
I'm going to kind of jump on the end of that related to a couple questions that came in about automatic shading and window coverings. So the first one was, were there any changes in considering window coverings like roller shades in energy calculations?
I think I answered that in the question and answer. There weren't any changes, but automatic shading devices are credited in the performance rating method. And there was another related question that somebody asked about when you would use performance rating method instead of ECB. And that's a good example when you've got some more advanced measures that are not available for credit in ECB, and things that come to mind are automatic shading devices, optimizing window area and daylighting, right sizing HVAC equipment, being purposeful in the type of HVAC equipment that you have, use of thermal mass, things like that you're credited for in the performance rating method. Natural ventilation, you're not credited for those in ECB. So I think in general, ECB is more appropriate for really simple trade-offs. If your lighting power is a little high in the building and you need to get a very simple trade-off with a little more insulation or a better window or something very straightforward, ECB might be an easier path, whereas Appendix G allows you a lot more flexibility.
Yeah, I think this is an important nuance that people need to sort of understand, that there are, the different trade-off options. We're introducing a lot of performance options for people, right? Because the industry is saying we want to be flexible, we want to have flexibility, but not all the trade-off options are equal. And some, depending on your strategy or your particular energy conservation measure, you may want to use a different trade-off. So we're building a standard to apply to a really broad section of the industry. People who want really simple things and just tell me what to do, and people who like, hey, I want to do like a net zero building and I got all this crazy stuff that I want to put in it. And I want to get credit for all this great stuff that I'm doing, and we have sort of the, Appendix G sort of at the end. And then we have all this other stuff in the middle. There's TSPR, we got, Appendix C, we got the simplified lighting building. So it does behoove the project teams to sort of, as they start in this sort of design phase, how they're going to comply, because they're going to need to tell someone, their engineer or whoever's doing their code compliance, what path they're going to follow. Because once you start walking down a road, you sort of want to there's other things you got to do. We could have a whole section just on the different compliance paths within 90.1, as opposed to, this is really just all the stuff that's new.
And I want to go back to Rose's earlier part of the first question. There is an daylight shading credit as well. So daylight shading is also has a role in certain parts.
Oh, great. Thanks, Michael. Okay, I'm looking at some of these later questions that have come in. A couple additional ones I wanted to hit on. Again, I know that the panelists answered some of these, but there seemed to be pretty good interest in a couple, so I'm just asking you to kind of answer them again for everybody. Another question about performance curves was, what is the implication of using different chiller performance curves between proposed and baseline models?
Well, typically you will use a different performance curve because the efficiency will be different. The IPLV will be different, so you'll be using a different performance curve.
Yeah, Mike, might be good to remind them, yeah, I mean, the baseline is 2004, so, you know, we've made significant improvements in chiller efficiencies in 2016. So you'll get significant credit for those performance curves.
Rosemary, I wanted to bring up the one question. There's a question about energy credits, and I think it would be important for people to know. So 90.1 is on continuous maintenance, which means anybody can bring up suggestions to change the standard. And in some cases, people or a particular interest group needs to change a base criteria. But if there is a particular strategy that is not captured in the energy credits, anybody is welcome to submit a continuous maintenance proposal. We call them CMPs, to sort of say, hey, I have this really great strategy that works, but it doesn't work for every building, but it works for a small section of the buildings, but it's a really great cost-effective strategy. We welcome that. I mean, I like to think that we're pretty well-rounded and we're pretty smart, but we're not sort of, we don't know everything that's going on. And as you guys know, stuff is changing all the time with this. So if you represent a industry or a manufacturer that has something that's pretty innovative, that is not focused on specifically, that's somewhat broad-based, it's not super specific, submit it, because energy credits is a great place for that to be, because it's sort of the stuff that doesn't apply to every building. It may apply to some buildings, and some people may want to use it some of the time and get some credit. And why not, right? We all want to save energy.
That was great, Lynn. Thank you.
Can
Okay,
I add a little bit, Rose?
Oh, go ahead.
Yeah, somebody who wants to get that in there, they may not have the capability or know how to determine the points to, award to that strategy. So I think instead of just submitting the proposal and having it incomplete, it might be good to reach out to the committee and say, hey, I have this great idea. Can you help us work with, can we work with you to help get it into the standard and help develop the credits? Because typically we do that via modeling that PNNL does for the committee. And all the prototypes that we use are posted online. So of course people can go out there and do their own analysis and submit it if they want. But also if they've got a good idea that needs help, it might be good to ask as well.
Well, Mike, since you're on, it looks like you started to type an answer to one of the more recent questions with the new backstop requirement for envelope being required for all pass and the use of ComCheck to confirm this backstop. Is ComCheck now needed even if going performance?
Yeah, and I guess maybe, ComCheck is not mentioned in standard 90.1. So 90.1, the envelope trade-off approach describes a rule set for doing a simulation, for doing your envelope trade-off. ComCheck is a tool provided by DOE to do that. So 90.1 doesn't require that, but the reality is that when people do that envelope trade-off, most of them, if not all of them, are using ComCheck, and jurisdictions often require ComCheck. So, if you have to ask that question, yes or no, ComCheck's not required, but in practicality, it may be, because in order to determine that envelope backstop, ComCheck is the best tool, or the most easily accessible tool to do that. So yeah, you probably do need to do a ComCheck as well as a whole building performance path using Appendix G.
Okay, thanks, Mike. Couple kind of logistical questions that have come in that I wanted to address. I have put in the chat the link for folks who want to get credits or a certificate emailed to them. Please go to that link in the next few days and give us your information, and you can get a certificate to self-report. If you're an AIA member, if you give us your AIA number in that form, we will report to AIA for you. Otherwise, it's self-reporting. And there also was a question about upcoming webinars and how to find out more. You can go to energycodes.gov. There's an item towards the bottom. One of the highlights is a highlight for the webinar series. You can click on that and get more information about our upcoming series. Also, if anyone has any suggestions for additional topics that might be of interest, we'd love to hear them, and you can send those ideas to us through the help desk link that you see on the screen right now, or email to me at rose.bartlett@pnnl.gov. We really appreciate ideas for future topics. Any last questions for the panelists? All right.
Great, thank you all.
Yes, thank you very much to all of you for joining us, and to all of the panelists. It was great. Thank you so much.
Thanks for listening.
Thanks.